Hello and welcome to YMT217 Programming Languages. We are still discussing preliminaries. This is the second part of chapter 1, so let's go ahead and see the topics. Actually, we have only one topic because it's detailed and extended, so what we are going to do is just discuss the language evaluation criteria. Now, before we go ahead and start discussing the criteria and their details, before that we need to describe or define what actually language evaluation means. Now, in order for you to evaluate something or anything, you need to have a way to assess it. You need to have a way to measure either its performance or its ease of use, or maybe something related to the time it consumes for you to learn it, or to do it, or to deal with it, and so on. So for programming languages, when we go specific and speak about programming languages, we need some set of metrics, or what we call evaluation criteria, in order for us to assess a language and say it is easy to use. For example, it's easy to learn, it's reliable, it's readable, it's possible to write a program in an easy way, and this is what we call writable. Okay? And it doesn't take much of time and effort to be learned. It's cost effective. So these are the common criteria that we usually use: readability, the ease with which programs can be read and understood. So if you have read a program and you would like to understand what it is, you go through it and you understand it, then in that case the language can be referred to by readable. Of course, we speak about someone who has some sort of level or some level of programming skills. We don't just bring someone as a beginner and we ask him to read and understand, or someone who has no idea about a certain language read and understand. That's totally different. So in that case, we have some certain level of programming language, and when we provide a ready program, if it is easy to read and understand, then we have some sort of readability level. Of course, this is not as straight as it seems. We have also a lot of measures for readability itself, and we will come to it in a while. Writability, the ease with which a language can be created, a program of a language can be created. So what we are looking for here is creating a program. And this program, is it easy to create a program? Regardless of the type of the program. Now, we don't speak about the length, but we speak about, let's say, a fixed application of maybe a couple of hundreds of lines. And in that case, if we compare multiple languages, how easy it is to write this program with these languages, rank it from 1 to 10, then we can say, let's say programming language A is more writable than programming language B, and so on. Okay. Reliability now, every programming language has its own specifications, or maybe we can say the data sheet, or the instructions with which it comes. So if the programming language confirms to its specifications and performs to its specifications, in that case we can refer to it by reliable. And we see also we have measures for reliability. The final criterion is cost, and cost is actually the total cost here. It doesn't mean in money, it's not necessarily in cash. It may be in time, it may be in effort, it may be in the resources it occupies, and we will see how we speak about cost when it comes to programming languages. Look at this table. This is extremely important and gives you an idea about these criteria that we measure or we evaluate a programming language with. By the way, before I go to those, these measures or criteria are not actually all the criteria that we can have to assess a language or to evaluate a programming language. No, there are others, but these are the most common, and we will be using them in our course. So for this reason, let's see what kind of characteristics control or influence these three. I didn't speak about the cost because it will come by in its time and by its own dimension, but let's just think about those with their own dimension. For this specific dimension, we can have even like intersection between certain characteristics like simplicity of reading, simplicity of writing, simplicity of a language that also influences the reliability. So simplicity of a language with its composition, it influences the readability, it influences the writability, as well as the reliability of the execution and compilation. Okay. Whatever else other than that in reliability. Orthogonality, that means independency. If the statements or the instructions, also maybe functions or routines of a language, have a little bit of, or maybe certain extent of independency based on their context or the used context, then we can have some readability level, writability level, as well as reliability level. So these two, both of them affect all the criteria. Also data types. Data types, you guys are familiar with data types. We studied this in Java before, if you remember. Primitive data types, maybe also user-defined data types, and so on. So these data types affect all the criteria, the readability, writability, and reliability, and we will explain how. Don't worry, we still have the slides to go for those. Syntax design also influences all of them. Why syntax design matters? Why matters? Well, if you are writing in a way that's close to the nature of the human being or the natural language, in that case, it will be readable. Also, it will be writable. And in the execution also, for maybe error checking, it will be also reliable. Why? Easy to fix it. Okay. Now we move to a second batch, you can say, support of for abstraction. Abstraction, you guys remember the concept of abstraction and creating, let's say in the simplest way, maybe classes and hiding data inside and just using their, for example, methods rather than whatever explanation inside these classes. This is a way to hide or ignore the unnecessary information from the reader, and in that case actually we don't have anything to do with the readability, it's about the writability, the easiness of writing the code. Readability maybe for excessive abstraction would be a problem actually. Why? Because it's not easy for you to read and understand in that case if there is an excessive way of using the abstraction, but for the time being we're just thinking about the writability, and it's good for it. Also for the reliability, it's good. It helps a lot with the reliability. Expressivity, that means how to express the language, how to express certain statements that affects exactly writability. It has nothing to do with the readability. And also the reliability, if it is complex in the way you express it, if it is simple in the way you express it, and so on, we will come to it. Type checking affects directly the reliability. It has nothing to do with the writability. It's something related to compilation and execution. If you have a way for checking if you have errors or not, now there are even like integrated development environment. While you're typing, it gives you even indication for errors, and that's very efficient in this case. Exception handling, you guys are familiar with exception handling, codes that are written for abnormal circumstances or situations that we may face or the program may face during the execution or during the runtime. So in order for us to avoid halting or anything that halts the program, what we do is we write an exception so that the program doesn't halt, but it gives us an indication about that abnormality. Okay, restricted aliasing. So this is like another factor for evaluation, and it's actually a matter of reliability, and we'll explain about it in a while. I'll leave it for its explanation until then because it's a bit specific. That's why I'll leave it to its slide. Okay. the criteria that we spoke about, we have the readability, writability, reliability, and cost. Now we will just go through them one by one, and we will see the factors that influence each and every one of them. The first one is the readability. We said the ease with which a program or a code can be read and understood. So you read and understand. What kind of factors that influence that? Simplicity for sure influences that. If the constructs or the features of the language are manageable, the set of all these features are, if we have a set of all these features, if the set is manageable, easy to be understood, then we wouldn't have much of a trouble. But now look at this. If we have an extensive set of features and constructs, a programmer may be aware of a subset of the whole set or a part of the whole set, but not all of it. So if another programmer writes from somewhere the reader is not familiar with, then we will get a problem with readability. That's why an extensive set of features, it can be an advantage. Why? It accommodates for many applications, and at the same time it increases the difficulty. So the difficulty in this case would be a problem with readability. Usually we have some sort of compromisation, so there is a certain compromisation between those, and this is another type of study. Usually we don't explain it much in undergraduate. I mean, this is a postgraduate course when we speak about optimization of these things. I mean, between simplicity and other features like maybe versatility, like how you create any or whatever possible with a programming language. In that case, you are ignoring simplicity. Let's move to the next minimal feature, multiplicity. Now, think about this. You guys are familiar with different ways for incrementing an integer variable in Java, and I brought this example specifically in Java because you guys are familiar with it. It actually applies to C and C++. Now here count equals to count plus 1. Okay, that means increment count is exactly the same. Or we can use the combined or abbreviated assignment statement, count plus equal 1. It's very similar to this. Post increment and pre-increment, actually those are a bit more specific and they have different meanings, but if they come on one line by themselves, just one line, each of those, they will apply to the same concept of those. They will have the same result. Otherwise, if it is an equation, yes, they have different representation and outcome or result. However, if we consider one line separate for each of those, they will apply the same concept and they will get you the same result. Now, this is what we call multiplicity. We have multiple ways to express the same scenario, and this is usually somehow a way of confusion. So that's why it should be somehow minimized. It's good and bad at the same time, but for readability it's bad. Why? Because if you are familiar with these two, maybe you may not be familiar with this one, you may be not familiar with this one, or you may understand it in certain context, you may not understand it in this context. I don't speak about extremely basic applications like this. I assume every programmer should be able to recognize this, but there are other things similar to this, which maybe 90% of programmers are not aware of. That's why I just brought an obvious example that we are aware of. Also, minimal operator overloading. If you remember about the operator overloading, we spoke about it in Java before. We may have an operator that can be understood in different ways. How? If the operands, let's say integer, we have two operands, and let's say we use an operator, let's say plus sign. In that case, it's an integer addition. Well, if one of them is integer and the other one is floating point, how it is understood? How about if one of them is integer and the other one is character? How it is understood? How about if both of them are character? So it's from the car type, 2 characters. How about if we are using the plus operator, the addition operator, this plus, for a single dimensional array operands? Are we adding the elements, or what exactly do we mean by using this operator? This is usually like a sort or a source of confusion in programming, and it actually creates something opposite to the simplicity of understanding or reading a written code. Orthogonality, I said about it earlier, it can be defined actually by independency. And usually when we refer to orthogonality, we speak about like how well we have sets of primitive constructs, that we can combine them, these small sets of primitive constructs that we can combine, and we can achieve whatever we want from the control structures or whatever needed in also data structures by the program. Why? Because usually we have primitive constructs independent. They are having their own unities, and they do not affect each other unless they're combined. And that's why how well we have this small set of primitive constructs in order for us to create the control and data structures of our program or the language. In that case, we can judge the orthogonality. Now, think about orthogonality in different aspects. Now, I will give a simple example that you guys had before. We have had it in Java. Do you remember when we create an array in Java? Let's say we create an array and we assign it the name of, let's say, A. And then we create another array, B, and we say B is equal to A. What happens? Now B and A take the same reference. If we change A, B will change. If we change B, A will change. So now we have 2 references referring to the same memory place or the same memory location, and in that case they are not independent, they are dependent. So we shouldn't actually allowing a lot of these in our programming. Usually this is common with pointers, like in languages like C++, for example, is extremely popular and has a lot of problems to do with arrays and pointers. Arrays are familiar in Java, you have already studied it, so you should know how these things may affect one another. They are a problem. In that case, they are really a problem. This is a lack of orthogonality, and you see how they influence one another and they create a problem with the readability also of the program. Okay. One more thing, orthogonality is also related to simplicity. Why? Because the less orthogonal, actually the more difficult. In that case, like this one, what are we referring to specifically in this case? Are we referring to more than one common block of memory, and that's not exactly readable? How may I know which one you are trying to do? Are you trying to change one and the other one will follow, or whatever exactly you are trying to do? In that case, it's a bit hard. Okay. Usually when we have less exceptions, as I said here, less exceptions, when we have less exceptions, it's more orthogonal, and it allows us to have a more clear view of the written text. Actually, orthogonality in this sense, or in this case, can be found in many languages more than others. One of the languages that has a problem or lack of the orthogonality is C. Now think about this. I'll give you just 2 examples. I'm not sure how much you're familiar with C, but think about this. In C we have 2 types of structured data. Structured data, that means that data that can combine more than one data type under the same name. Okay, we have the structures or the records, and also we have arrays. Now for arrays, we may have any data type now, any data type that you want in arrays, but the problem in arrays, if you want to create something like return type, now we get to exceptions. Okay? Now think about array. In Java we can return it from a function or a method, but in C programming we can't. We can return in C programming a record or a structure, yet we can't return an array. And this is a problem with orthogonality in C, specifically in C. Also, think about the way we define members of a structure. How about the structure itself? We can define any data type inside the structure except two data types. The first one is a void. Void is not permitted in a structure. And another type, the structure itself, the structure that we are creating, because we can create a structure with certain name and becomes a data type, we define it. And we can't use that one as a member in this case. How about arrays? Arrays, you can have any type except void or a function. These are also exceptions. So these usually create a problem with orthogonality. I explained about those earlier. I mean also the misplacement of elements. Okay, so these are common questions. I may ask such questions on the exam. Let's say I may ask you a question like this. Give an example of lack of orthogonality in C, for example. Or I may say something like this. If pointers are not allowed to point to arrays, simple example like this. What may happen, or how can we judge a language that has pointers functionality, but they are not allowed to point to arrays? Then also this is a lack of orthogonality, because they are supposed to point to whatever designed as a data type, including themselves maybe, or arrays also. So that could be a question. Okay, I'm telling you about the type of questions I'm asking. Why? So that you don't be shocked during the exam or the quiz. Actually, we will have quizzes, so you don't have to worry, and you will see these questions and you'll be familiar with them. However, it's good to know from now what type of questions that I'm going to ask. Data types, the other evaluation criterion for readability. Data types, as I said earlier, we have different types of data types, considering different programming languages. Now, what could be the problem with readability if we have data type as a consideration here in this case? Now, do we have adequate data types? This could be a question. If we don't have adequate data type, we are enforced to create them. Creating them is actually time consuming. This is number one. Number two, they may not be readable. Okay, why? Any user defined thing may not be easy to understand. It depends on the type and the mood of the developer, and we don't know exactly what type of developer he is. He's expert, or he's writing in like a mysterious way, or the code is vague. But if it is standard from the language itself, people will be familiar with it. Now assume that a language has no Boolean type. If we don't have a Boolean type, in that case, let's say we want to create a flag. The flag in this case, we have to replace the Boolean type by another type. It could be a numeric type like this. Let's say timeout is equal to 1. Timeout is equal to 1, we need to sense 1. But for a person who is reading your code, not you as a designer, would say this is an assignment of an integer to an integer data type. So what's the point here? Compare it to the following. Now when we say timeout is equal to true, the first thing comes to our mind is this is a flag. Why? Boolean type is, if you remember from Java, is composed of two, and the two choices, true or false, and we usually use them as a flag to tell if a changeable thing based on certain condition. Okay, But this one is a numeric. We're not quite sure. Maybe the developer is familiar with it, but we are not. And we need to consider it exactly as an assignment of a numeric value. Okay? So that could be a problem with the data type. Syntax consideration. Now, syntax is extremely important. Why? It influences the readability. Now, think about these keywords or special words. What comes to your mind? Immediately loop, if, condition, else, also a part of the control structure, while, a loop. So of course we have a condition to be maintained while the loop is running. However, the idea is like this: we human beings respond to whatever we have in our own natural language and we apply it to programming language. So syntax consideration also influences the readability by special words we use, because they make sense in our own language. Also the form and meaning, the semantic, not the syntax. When we say about the meaning, we speak about the semantic. So the semantic, now if we are writing with special words, and also if we are creating our own data, it should be somehow meaningful. Why? It should indicate what kind of purpose we are creating or we are writing the code for. Okay? Now look at this. I'll just give a simple example also again from C. We use a lot of examples in this book from C, C++, and Java. Okay, with other, of course, with other programming languages, but usually from those more than others. Now look at this. If we consider the word static in C, it may mean different things. And this is a problem. Usually when we think about the clarity of the syntax or the meaning. Now, if you use static for a variable inside a function, now function is a method in Java. We call it function in C and C++, or subroutine if you like, or modular program. It's a small part of the program. We create it for a specific purpose. Whenever we need it, we call it. So if you think about a variable, you guys know what variable is. I don't need to explain it. If we call a variable static, if we define it or declare for it as a static, then what will happen? It will be created during the runtime. During the compile time, not runtime, during the compile time. But if you write this variable outside of all functions inside a file, it would be available for that file. It won't be exported from that file. Okay, there is a missing word, I'll fix it. It won't be exported from this file actually. So the idea is like this. What we are going to have here is something like two meanings based on the context. And this is a bit of a problem when we speak about semantic, the meaning of the expression or the statement in this case. This affects the readability. And the more meanings we have for the same keyword or for the same instruction, the less readable the code will be. And that is one of the problems we may face with readability. Writability is closely related to readability. Why? Because if the file or if the code is readable, most likely it was writable in the first place. Okay? If it is writable, most likely it will be readable next to that. So this is usually the case, okay? But we have also some other, we have common and separate characteristics or criteria for measuring or evaluating the writability. Now we said earlier how easy to create a program by a programming language. Well, this depends on actually the domain with which we are writing a code for. It matters. Why? What kind of domain you are writing a solution for? Is it for system, operating system? Is it for a game? Is it for a web application? It depends, because in some cases we have to write really in a tough way in order for us to create that program. Why we need to use uncommon maybe codes and expressions in order for us to get the expected outcome, okay? So we said about the readability and writability, they are actually influenced by common characteristics. However, there are some characteristics restricted only to writability. Now, simplicity and orthogonality, they affect both. So I don't have to explain the simplicity and the orthogonality. Again, few constructs, small number of primitives, small set of rules for combining them, creating robust code that will make the code writable and readable in the same time. And let me get you back again to the table. If you remember, I said simplicity and orthogonality apply to the same readability and writability. Data types also apply to the clarity of the writability, so I'm not going to consider it here. We explained about it. How about the support of abstraction? I said earlier in that table, I spoke about it in brief. Now, in order for us to avoid any irrelevant information from the reader, what we do, we create our own abstract data type, and we encapsulate the information somewhere, maybe inside a class or an abstract class or an interface or whatever. So we keep the information hidden somewhere which is irrelevant. So we ignore the details and we keep the relevant information through maybe methods or whatever relevant to that. So the user will just deal with those who actually needs to know or who should know, so that he does not, or he or she does not, or won't bother with the details. The more abstract we have, the more writability level, or the higher the writability level will be, okay? Or the better actually writability level will be. We said about the expressivity. The expressivity is actually the way we express or we provide a statement for the program. Now think about a way we explained a while ago when we said about count plus plus and count equals to count plus 1. Now look at this. This is shorter and more convenient than this. If they have the same meaning in this case, if we are looking for just incrementing the counter, then this one is more convenient and it's more expressive. So it's more expressive and it is it's shorter, less troublesome in typing. Okay. Also, we may think about the operators. Do we have a good set of operators, predefined functions that we can use? Do we need to define a function whenever we need the functionality? Do we need to define a function, or we can have a ready function built in so we can use it? So this is what we refer to by expressivity. Okay. Reliability. Reliability, we explained about its definition. It's like if the program confirms with the specifications, is it up to the standard, its own specifications? It performs based on the specifications or not? If it is, then we call it reliable. But how can we judge? We have different characteristics to judge. The first one is type checking. Type checking is like this. Let's say before you execute the program, or even while executing, but before execution is much better. Before execution, let's say when you compile the program. Now there are compiled language and there are interpreted language. We'll speak about the differences between them later on. For compiled languages, in order for us to run them, we need to compile them and see if there is any problem or they are error-free. So if we compile the code, or even before compilation, if we have a type checking functionality tells us about the error in advance, then that is really reliable. When we go to runtime checking, if while executing we get an alarm about an error, then that is really expensive, because we will have to go and debug from the beginning or try to see where the error is. Well, while we are writing the code, or before compiling or during compiling, if we have an idea about the errors that we have, especially in typos, that would be great. Now, most of the IDEs or the integrated development environments provide that. You guys are familiar with NetBeans. We worked with it while coding in Java. It shows the errors while writing, while typing. So these errors will be highlighted with certain swirly lines while writing your code, even before compiling, and letting you know that there is a problem with these written, let's say, instructions. Maybe it could be a typo, it could be a misuse of an operator, or maybe a variable which is not initialized and being used, and so on. Also, exception handling. We explained about this one quickly earlier. Now I'll explain about it a bit in details. Now, for exception handling, it is actually a characteristic for measuring the reliability. Why? It is not recommended to have your program halt. Halt means stop, not executing, not giving you anything, or providing you with nothing in the output, and you are not quite sure why your program goes to that kind of outcome, or it may give you a weird outcome. So in order for you to avoid it, to avoid this interruption during the runtime, what we do is we create something we call exception handling. Now it depends if the language is providing you with exception handling ability or not. If you have this kind of ability, you can just create some exception handling scenario, and it will help you to avoid any interruption during the runtime. And that is actually perfect for measuring the reliability. Aliasing is actually using, I said I'll explain about it later when we reach to it. It's a bit unique and new maybe to you. That's why I said leave it to the end, to its own slide. Now think about this. If we have two or more methods or ways for referencing the same memory location, in that case, we spoke about this one earlier, about the same way. If we are pointing to the same memory location with the same reference, okay, this is very similar. In reliability, when we have this aliasing, we may have a problem with the execution, okay, or we may have unexpected outcomes. Why? Because if one of them changes undesirably, then we will have the other changed, and that would create a problem in our own results or unexpected results. Readability and writability, we explained about this earlier, that readability and writability, they have their own relationship together, and now the new part is they really affect the reliability. Why? If you are writing a program not in a natural way, in an unnatural way or unnatural approach, it will be really hard for it to execute. It will be difficult for people to read and debug it, and that reduces the reliability. And this is among the characteristics of reliability. So easiness of debugging, of fixing errors, of reading and finding the mistakes or the bugs in the program. Okay. One more thing I forgot about earlier while explaining. Now I will just say about it. In reliability, also we think about, here I said about the writability, I said about it actually. In reliability, we think about also the efficiency of writing codes. If the code is running in an efficient way or not. And this one by itself is a topic, we'll speak about it in a separate chapter and later on. And also you guys will study it in data structure. Now you are taking a course in data structure. You'll understand the efficiency of executing a code, or the difference between efficiency in terms of time and in terms also of memory consumption. Okay. Now let's go ahead to the last criterion, the cost. Now the total cost of a programming language is not just the money that we pay for it. There is no such thing. What we refer to by cost here, the cost of training people to learn it, to learn the programming language. Now the cost, the training cost may be money, maybe time, maybe resources. So you think of all these all together, okay? Also, writing programs, the cost of writing programs, time, effort, number of crew, and so on. So this is influenced by what? What kind of influence that affects writing program? Go back again to simplicity, orthogonality, all those, because it's writing, right? So if it is close to the application or not, if you remember, I mentioned once about, during this session, about whether the program of choice or the programming language of choice fits the application that you are looking for or not. So you may waste your time writing a code by a programming language and then you say it's a bad language. It is not. You are not choosing the right programming language for your application. So this also matters. If it is close to the particular application, this matters. Okay. Compiling programs actually have their own cost. Why? Is the programming language easy to compile? Does it consume much of resources while compiling? Does it show me errors and whatever in terms of before compiling or while compiling? Does it make my machine stuck by consuming all the resources? Does it take too much time? These are actually factors of cost in this case. The same goes to executing programs. Does it consume a lot of my memory? Does it load my operating system? Does it take much time? Do I get stuck a lot with execution? Do we have like, let's say, runtime error with no reason? So all these things matter. Also the implementation. Language implementation system. Now think about the programming languages in terms of their own cost. Some programming languages are set free of cost. Now you guys used Java before. It's free. You can download a lot of its integrated environments, or you can use even online compiler for it. So it's free. It's totally free. You can have integrated environment to use it, to build programs with it, or to create even software with it. It's totally free. That's why it's popular. Also, most of the programming languages which are free, usually they become popular if they are versatile. You can use them in many applications. All right. The cost, reliability also troubles the cost or affects the cost in terms of the poor reliability. If a programming language has a poor reliability, and we spoke about the factors that affect the reliability, if we have a poor reliability, then we have a higher cost. Why? Well, execution time, errors, problem with maybe writing, problem with debugging, and so on. We have one more thing, and this one I explained to you, if you remember, last semester in Principles of Software Engineering. Yes, we spoke about the maintenance as a part of software development. If you remember, also it applies to programs. Maintenance itself has its own cost. Usually, the easier a program or programming language can be maintained, the better it will be in terms of quality, the less in cost. Okay, so maintenance, usually in this sense, we are not looking for an update. We may make the maintenance on our own. Let's say we have a missing, we can add it, or we have a certain problem, a bug, we may fix it if we know the implementation of the programming language itself. And these are actually the common criteria we spoke about, the common four. Now there are others, let's just go through them. I mean, generally in a very general sense, we have the portability. Are the programming languages that we are discussing portable? They apply to different platforms. Can we implement them, install them, use them throughout different platforms, or we can just use them with payable, with expensive operating systems? If in that case we need to have a certain operating system, maybe not a free operating system, we are in trouble. Why? people usually try to make use of whatever free as much as possible for many reasons. Okay, and if you have like a cross-platform application or programming language, then we call it portable, and in that case, it will be actually more popular depending on its versatility. Generality, for the generality, now we have what type of applications can we create, or what type of programs or software packages can we create with this programming language. If it is applicable to many or to a wide range of software packages, then it would be a good type of programming language. Also, we have the well-definedness. The well-definedness is if it has like a complete set of instructions, precise definitions, okay? And also like you can say we have what we need from its help, the menu that we have in its help. So all these matter actually provide for a good programming language characteristics, okay? So these are important, and we need to go through them as characteristics of measuring how good a programming language can be evaluated, or how can we evaluate our programming language or the language of choice in terms of its performance. Okay, this is the end of the session. We will have another session for the same chapter. Until then, have a good time. Goodbye.